Good morning, dear students. In last class, we discussed about the spring pendulum. That spring pendulum is here. In that spring pendulum, we discussed one thing, that is that oscillation of a spring or oscillation of a body which is connected to a spring is there. In this spring pendulum, the spring is elongated and the compressor is there. Okay. If it is elongated, it is due to when you pulled this one, or you can push. Okay. If you push now, that's why it become what? Compressed. If you pulled like this, it gets elongated. Okay. If you applied some external force F, that is pulled, external force F, the body will displace up to from initial position to here y is the displacement of the body. At that situation, the spring is just elongated. If you remove this applied force, then this body starts to oscillate by repeating its mean position from here to here. After that, it reaches the same displacement, it covers the same displacement at here. Initially, if you apply the external force, if you pull like this, the some displacement is covered by the body or the particle. And if you remove the external force, it repeats its initial position and covers the same displacement at another side of its mean position. The same displacement is there. At that situation, this spring just compresses like this. Okay. In this situation, if the force is, when it is compressing, the force is there, it means when the applied force is removed, it gets compressed due to the restoring force. That restoring force is always directly proportional to what? The displacement of the body, but it is a minus sign because the displacement is away from the mean position and the restoring force is towards the mean position. If you remove the proportional sign, F Re is what? Equals to K into Y. K is called what? Spring constant. Where K is the spring constant. I will write here only. Okay. The same term is there. In this spring block system, one thing is very important. Spring block system. We already know one thing, the restoring force is directly proportional to the displacement of the body. The restoring force is directly proportional to what? The displacement of particle, from mean position, Okay, I will draw its diagram. This is called a rigid support and this is a frictionless. Surface. Okay. And here we attach to one spring like this. This is a mass of the body. When the displacement, it is called initial position is called what? The mean position. This is called what? The mean position. When it is moved away from the mean position, its displacement is here. I will draw directly here. I will draw directly. When it takes the new position, it is the displacement of the body. It is the displacement of the body from its mean position. When the external force is removed, it just compresses. It just compresses up to here. It means it is the another position of the particle, like this. Okay, this is what the same displacement is there. This displacement is directly proportional to the restoring force, or the restoring force is directly proportional to the displacement of the particle. It means just FRE is there. When this external force is removed, external force is always towards the mean position, like this. FRE. This FRE is a restoring force which is directly proportional to the displacement of the particle with minus sign. That minus sign indicates what? The restoring force is opposite to the displacement of the body. Restoring force is towards the mean position and the displacement is away from the mean position, like this. We have to take the initial displacement. Okay. Next, if you remove this proportional sign, what happened? The restoring force is equals to minus of k into y. Here k is called a spring constant, where k is called spring constant. Spring constant. This spring constant is always depends on the restoring force as well as the displacement of the body. Both. Okay. Now, if you write like this, then displacement, it is the restoring force initially. Then what is the form of this spring constant? This spring constant form is k is equals to what happened? Minus of y divided by f. Sorry, it is equal to minus of f divided by minus of restoring force divided by displacement of the body. This is the spring constant. Very simple. Its definition is, the spring constant definition is nothing but it is the ratio of restoring force to the displacement of the particle. What is that? The ratio of a restoring force to the displacement of the body is called the spring constant. Okay, what is the SI unit of this one? SI unit of spring constant is, here the restoring force is a force, so force is denoted in terms of what? Or unit of force is Newton, and this is a displacement. The unit of displacement is meter, but it is in the denominator, so it becomes what? Newton per meter is the unit of what? The spring constant. Then write the dimensional formula. What is the dimensional formula of this spring constant? Newton is nothing but a force. That force is force equals to m into a, that is mass into acceleration. If it is mass into acceleration, mass in terms of kg is there. Okay, the mass is there, and acceleration is meter per second square. Length is 1 unit and time is the per 2 units are there, and another one is meter per meter is also there. So it becomes what? Newton is nothing but what? M L T raised to minus 2 is the force here, and per meter is length, it is per length. Then L minus 1 is there. If you expand this bracket now, then what happened? Its dimension formula is mass, length here plus 1 minus 1 gets cancelled, it becomes minus 2. That is spring constant dimension formula. Then the next part is here. The next part is the combination of the springs. Before this combination of springs, we have to discuss about the sum spring constant. We have discussed or the some springs are there, or we have to discuss the some important concept or important points are there. First one, very important points. Here, the spring constant is directly proportional to what? The restoring force. But what about time period? We already know that the time period of a block spring system. What is the time period of block spring system? We already discussed this time period of a spring here. The spring is, according to spring is there, okay? According to spring block system, according to spring block system, this K is there. Then K is there and restoring force is there. This restoring force in spring block system, the restoring force is equals to minus of K into L, because L is nothing but what? The length of the spring, where L is what? Length of a spring. Length of spring. You can take here Y or L. L is nothing but length of the spring. If the spring is just elongated, what? There is a change in length. If it is the initial position of the spring. Okay, I will draw here. It is a support. If it is the initial position of a particle, when it is hand freely, there is the acceleration due to gravity. Gravity is applied. Okay, the body is under gravity. It is moving downward. It means what? If it is a length, the body at here is a mean position. It displaces here. It means it come down. If it is come down, the displacement of the body called is x or something y. X or y is there. The length of the spring is just changed like this. Initial length is L, then from here to here, this become what is L dash. L dash is nothing but L plus of Y or X, displacement of the body, like that. Next, the time period is there, right? So it is like this. Then what about time period? The time period is T is equals to 2 pi divided by spring constant K is there, the spring factor is there, and mass of the body M is there. It is called inertia. Inertia is there. Then what is the relation between the spring factor, the inertia factor, and time period? That is nothing but T is equals to 2 pi into M divided by K. M divided by K. It is the spring time period of a spring block system. Okay, the next part is here. Remove here. Then next is here K is there. Then if the restoring force is constant, then what about here the spring constant? Spring constant is inversely proportional to what? Length of the spring. So very important points are there. It is inversely proportional to what? Length of the spring is there. If it is length of the spring inversely proportional means K is, take the minus sign as a constant, force is a constant. If restoring force in this one both are constant, K is inversely proportional to what? 1. L is there. That is, it is inversely proportional to L. It means if the K increases, the spring constant is increases, then the length goes on decreasing. If the length is decreasing, what about time period? The time period is what? Is also decreasing. What are decreasing? Now, the next is the time period. Come to the time period. What about the time period is there? Next one is the time period of a body which is under gravity, that is G. If it is the one body is just under the action of gravity, it means what? The spring is there, the body is also there, but that body is under gravity. It means what? The body is hanged. Okay. If it is a rigid support, one spring is there and one mass is attached to the spring. This is just hanged. Now, this spring length, call this is L, and its constant, spring constant is also there, that is K. When it is hanged freely, it is always moving downward because of the weight of the body. That is called weight of the body. Due to the gravity is there now. So that's that. It is always directed towards the ground. That is because of the force mg. It is mg is there. When it is just hanged, when after a certain displacement, after covering a certain displacement from here to here, it again reaches its initial position and it covers the same displacement at the mean position, from the mean position. Due to the restoring force. Here the restoring force is there, or it is also called here tension. Okay, it is called what? Tension. Then it is mg is there. Here restoring force is also there. Then mg is, what about the time period? Now the time period become, we already discussed it. That is nothing but the acceleration and g is there. Now the acceleration is nothing but acceleration due to gravity, and displacement is there. That displacement is nothing but what? Consider here length is there. Okay, here what? That is displacement is nothing but L. And gravity or acceleration is nothing but g. The time period is nothing but what? L divided by g. It means 2 pi under root L divided by g. This is the equation of simple pendulum also. It is equation of simple pendulum also here. That is placing where L is called what? The elongation or compression of the spring. Elongation or compression of spring, and g is there. G is what? Acceleration due to gravity. Here acceleration due to gravity is always what? Constant. Always constant. Then it is constant, 2 pi, it is for one revolution or it is one cycle. 2 pi it is also constant, g is also constant, then what? The time period is directly proportional to the square root of the length of the spring. That's very important point. What is that? The time period of the spring which is hanged freely. Okay, it is directly proportional to what? Square root of the length of the spring. Okay, here the time period is directly proportional to what? Square root of length of spring. Length of spring means that T is directly proportional to root of L. If you draw the graph for the time and length and time and square root of length, these two are directly proportional, means if the length increases, the time is also increases linearly. When it is the graph for time and square root of L, if the length increases, the time is also increases linearly. Both are linearly here. If you draw the graph for this one, for time and only length, not square root of length and time is there. The graph for time period and length is there. The length is increasing slowly, the time period is increasing there. Both are increasing. Then I will draw the graph for here K and L, and another one is the two graphs of time period and length and time period and this one. One thing, the graph for first one. Graph for what? Spring constant, that is K, and another one is what? Length is there. Here inversely proportional. If the length decreases, spring constant increases here. Inversely proportional. Now, along y-axis I will take the spring constant, and along x-axis I will take here the length of the spring. Now, if initially the spring constant is more, the length is what? Very less here. At y-axis, x component is 0. At x-axis, y component is 0. At here, initially the k is more. K is up to here. That length is 0. Okay. Now here the k goes on decreasing. Then length goes on what? Increasing like this. Because if it is decreasing, it should be increasing. Those are inversely proportional to length each other. Okay. Then k is inversely proportional to length of the spring. Then another one is the graph for what? The time period. Graph for time period with what? Another one is length. Only length. Not square root of length, that is only length. There are two graphs. I will draw two graphs. First one is the time period along y-axis. Take the length along x-axis. If it is length along x-axis, time period is along y-axis, it is origin. Now, in this graph, the time period is increasing, but the length goes on what? Increasing slowly. Like this. This is a graph for what? Time and period. And if you draw the graph for the time period and the length, square root of length, time period and the square root of length is, these two are directly proportional, but these are linearly. So this is a graph for what? The time and the square root of length. This is a graph for the time is directly proportional to square root of length. This is a graph for the time is proportional to only length. Okay? Yes, these are the graphs of that. The next important point, the next thing, the one body, if the two bodies are connected with a single spring, then what is that? If one body, two masses are there, okay? If two bodies are attached to a spring. A single spring is there. Na? So if there like this, it means the one mass is there, that is called it is the M1. Those must be different. Okay. Then another one is the spring is there, and the another end one more body is attached whose mass is M2. Both are kept on a frictionless surface. If it is a frictionless surface. Next, if you draw this like this, there are two masses. We have to convert these two masses or combination of these two masses here. This is the spring constant K. Then what is the time period of that? The time period of that is, we have to, in that collision of the bodies, in work, energy and power, the collision of system of the particles are there, or system of two particles are there. If both bodies are moving like this, if one body is M1 and another body is M2, one body is moving and here like this, when these two are collide with each other, if it is moving like this, the velocity of, it means the initial velocity of this one. Okay, the initial velocity of the first body U1 is more than the initial velocity of the second body. After a certain time, this body M1 can hit the second body. After a certain time, this M1 can hit the M2. At that situation, what about the mass of the total mass of the combination? The total mass of the combination already derived in that chapter. That is called reduced mass of that. If the two masses are there, we have to derive a combination of the two masses. Now, mu is the total mass. Call this mu as a total mass, or it is called a reduced mass. Its equation is nothing but M1 M2 divided by M1 plus of M2. These two are connected to a single spring. Okay, two are connected in single spring, where mu is called what? The reduced mass equation, or it is a reduced mass of the combination of the two masses. Then when these two are connected in this one, what about the time period? Then already we know that the time period equation, the time period is equals to 2 pi under root mass divided by what? K. Here the mass is what? Reduced mass. It means the combination. Then what? The time period become the 2 pi under root, that mass become mu, that is the reduced mass, then divided by, it is a spring constant. Spring constant is there. If the two particles are connected to a single spring, we have to convert into reduced mass, that is M1 M2 divided by M1 plus M2. Okay. The next thing is one more thing is there. It means one block is one mass is just kept on the block, one wooden block is there. Okay. Like this, one more is the block of mass M, small m, is kept on the surface or on another block. Okay, another block is there, another block attached to a spring, there one spring only. It means one rigid support, and this should be a frictionless body or a frictionless surface is there. There should be a frictionless surface. One spring is there. That spring is attached to one block, Call its mass as a capital M. Capital M. There is no friction between this surface because this surface is a frictionless surface. Frictionless surface is there. Then another body is there. That body of mass is M. Okay. Another body is kept on that body. There is a friction between the two surfaces. There is a friction between what? The two surfaces. Okay. Then the spring can elongate or compress. Elongate or compress continuously. But what if this mass is not dropped from this other block? Okay. Next, when it is, what is the time period of that? What is the time period of this mass? Now, first we have to check what are the forces on this block body. What are the forces on this body? I will draw here the free body diagram. One is only this body is there, whose mass is M. Always its total mass is there, that M is there. This body is kept on the another block, but it has a certain weight, it has a certain mass is there. So it has certain weight, that is called weight of the body. It is under the action of gravity. So under, it means towards the earth, always the force mg is there. Mg is there. And in upward direction, the normal reaction is also there. And when it is continuously elongated, it means it is elongated, compressed like this. That body cannot drop from this other block. Okay, from this one. It means what? There is a friction between those two. If I am standing in this table. If it is table, I am standing on that table. There is a friction between me and that table. When it is just moved from this point to the another point to that same point is there. If I will not, it means skip from that body, slept from that body. What happened? It is nothing but what? There is a friction. It means what? There is a friction between the two bodies. There is a friction is there. Here the friction is there. Call this friction as a F. Okay. According to the definition of the coefficient of friction, that is coefficient of friction is the coefficient of friction mu, not this mu. It is a reduced mass. This is a reduced mass, and this is the mu is nothing but what? Coefficient of friction. Coefficient of friction. The coefficient of friction is nothing but the frictional force to the normal reaction. Frictional force to the normal reaction. Then this frictional force is equals to what happened? It is equals to mu is the coefficient of friction and also the normal reaction. But what is the normal reaction? Here the normal reaction is upwards, and in downward direction the mg is there. According to the law of equilibrium of forces, then R is become mg because both are in opposite direction. According to equilibrium of forces, R is plus. If it is R is plus, mg is opposed to that is minus mg. It is equal to what? 0. Then R equal to what happened? mg. Then substitute here. That frictional force is equal to mu into mg. Mu into mg. But the frictional force is there. Call this frictional force. It means what? If you apply the force, that external force MA is there, and it returns back due to the restoring force is there. You can take that force as a M into A. Okay? If you can take this one as a M into A. This is M into A is there. Call this A is an acceleration of a body. That is mu into m into z is there. These two gets cancelled. That acceleration is equal to what? Mu into z is there. Mu into z is there. Then what about the time period? We have the equation for time period, that is nothing but the mass divided by k. Then k is also there. Then a is there. Then a is equals to there. The next part is here a is the acceleration. What? Where a is the acceleration of the body. It is continuously oscillating now. That body is continuously oscillating means that executing what? Simple harmonic motion. The magnitude of acceleration is what happened? The acceleration, that acceleration is equals to magnitude is nothing but our maximum acceleration. You can take the magnitude of the maximum acceleration. That maximum acceleration is equals to what happened? Omega square into a, where a is called what? This a is an amplitude. Where a is called what? The amplitude, or it is a maximum displacement. If you write here, if you write like this, then a is equals to mu into z is there. Then omega square into a is equal to what happened? Mu into z. We want the time period. So we want time period. Then omega is nothing but omega square is there. If you want the value of omega, then here it is in the numerator. Then you take the to the RHS, that become a denominator of that. Mu into z divided by a. It has a square. Then that become what? Square root of that. Square root of RHS. It is what? The angular frequency or the angular velocity. The next is the time period. We want time period now. Now the time period is. The time period is omega is equals to 2 pi divided by t. Then t is equals to what? Then t is equals to 2 pi divided by omega. 2 pi divided by omega. Then time period is directly, I'll write here. The time period is directly 2 pi under root reciprocal of these two. Reciprocal, that become what? Maximum displacement is amplitude divided by coefficient of friction into z. It means the one body is kept on the other block whose mass is just neglected here. This mass is there. It is the one body. In between these two bodies there is a friction. In between those two bodies there is a friction like this. Here it is R and downward is mg, and here it is frictional force. Okay, due to that the time period is like this. Next thing, the combination of the time period, combination of the springs. We have to connect the one mass in series combination or parallel combination of two or more springs. Combination of what? Springs. First one is series combination. If the two or more springs are connected end to end is just I'll say just one game. It is a thing, but if you connect it like this, simple game. In Kannur, nearly two friends, new friends idiri. Then this is one end. If I am a spring here, there it has two ends. One spring, one end hage bidona. Innond end idare. Next, another spring is there. That another spring, it has also two ends. Adakku kuda two ends irtavu. Allidinda one end anna tandu ಈ ಕಡೆ ಇರತಕ್ಕಂತ ಒಂದು ಎಂಡಿಗೆ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ರೆ ಆ ಕಡೆ ಸ್ಪ್ರಿಂಗ್ ದ ಎಂಡ್ ಏನಾಗುತ್ತೆ, ಆ ಸ್ಪ್ರಿಂಗ್ ದ ಎಂಡ್ ಏನಾಗುತ್ತೆ, ಖಾಲಿ ಆಗುತ್ತೆ. It means one is connected. So it means what? Both friends, these two friends are in series combination. Means one end is just connected like this. Okay, one end means here. If you connect in series, na, so if you connect the series, one rigid support and the frictionless body, one spring is there and whose spring constant is K1, and another one is connected to this rigid support and one end of the spring is connected to the another spring. That spring is K2, its constant is K2. After that we will connect the both springs to the mass M. This is a frictionless surface. If it is the frictionless surface, negative the friction here. Okay, these two are connected in series or another. If those two are hanged, This also the diagram for this one. If it is a rigid support, one spring is connected like this, and another spring is there, and the mass is attached to the springs. Call the spring constant is K1, call the spring constant is K2. We already know that the restoring force, I'll take here restoring force. We already know that the restoring force is directly proportional to the displacement of the body. Or directly I'll write here K into displacement of the body. In this series combination, the very important point is there. What is that? The body is just moving continuously. It means the spring is elongated and compressed continuously in this series combination. In series combination, the force, that restoring force of these two springs are always what? Same. Okay, in series combination, what is that? The restoring force of each spring. It means the restoring force at everywhere is always same. It means the restoring force is constant. That FRE is constant. If the FRE is constant, what about the displacement? Displacement, it means the time period is depends on what? The spring time period is depends on the displacement of the body. Only the displacement of the bodies. Then its combination is there. And what about this one? K1 and K2 are there. You can take this formula. This is what the effective force. Okay, first one, effective, I'll write directly. Effective, what the forces are there here, 1, 2 points are there, forces and displacement is also there. The force is constant. Now the effective spring constant is effective spring constant. Call it is in series combination, call it this is Ks. Okay. Next, Ks is equal to what? Here, Ks. We have to calculate what? Ks. Effective. Then Ks is equal to, we have to calculate Ks. Then the effective displacement is, what is that? The total displacement. The total displacement is, call it is, y is equals to y1 plus of y2. y1 plus of y2 is there. The elongation of the first spring is different as compared to the elongation of the second spring. This elongation of both springs are different here. So it is y1 and y2. Or length of the springs also different. Consider like that. Then, if you like this, y is equals to what? It is called the total displacement of the combination. y1 is the displacement of the first spring, y2 is the displacement of the second spring. Next, y is equal to, using this equation, directly I will write here, that I will write restoring force is constant here. Y is equal to what happened? That restoring force with the minus sign divided by, it is a total, so it is called what? Effective spring constant Ks. Then here also restoring force is there. Y1 is equal to, again, y1 is equal to what happened? K1 into restoring force. y1 is equal to what? Minus of Fre, because force is constant here. Restoring force is always what? Constant here. Minus of Fre divided by, it is K1. Then plus. Then again minus of Fre divided by K2 is that. But here in RHS and LHS, the restoring force is common. If you take the restoring force as a common in both sides, the restoring force gets cancelled here. Okay, Fre with minus sign. Minus Fre divided by series combination, effective spring constant, it is equal to minus of Fre is common here, minus of Fre is common, the remaining part is 1 by K1 plus of 1 by K2. 1 by K2. These two gets cancelled. Then what happened? 1 divided by Ks, series combination, is equal to 1 by K1 plus of 1 by K2. 1 by K2. When the springs are connected in series. When springs are connected in series. Okay, now the time period is, what about the time period? The time period is, T is there. We have time period equation, 2 pi divided by mass divided by K. Mass divided by K. Then K is nothing but what? This is connected in series. These two are connected in series, that become what? K. Yes. Then what happened? The time period is equals to 2 pi under root. It is called, we can take, it is directly Ks equal to, Ks is equals to this, like this. Okay, Ks equals to 1 by Ks equals to 1 by K1 plus of 1 by K2 is there. Okay, or you can write this is, take LCM and here totally Ks is equal to what happened? LCM is K1 K2 and K2 plus of K1 is there. Denominator multiplication and cross multiplication. Reciprocal of that one, that become what? K1 K2 divided by K1 plus of K2 is there. Let's substitute this value in this time period, that mass divided by K1 K2 divided by K1 plus K2. The denominator become a numerator, that become what? K1 plus K2. K1 plus K2, it is a time period of what? The series combination of a spring. If it is a time period, then what about the frequency? The frequency time period relation is, the frequency nu is equal to 1 divided by t. Reciprocal of time period is nothing but a frequency here. Then you can take that frequency is nothing but the reciprocal of this one, the reciprocal is equals to 1 divided by 2 pi. Reciprocal of this one is k1 k2 become the numerator, k1 k2 divided by m into k1 plus of k2. Okay, this is what the frequency. If you want the angular frequency, for angular frequency then what? Remove this 2 pi. Remove this 2 pi only. Okay. Next one is parallel combination of springs. I'll remove this one. Next is parallel combination. Parallel combination of the springs are when those are connected. Parallel combination means the both ends are connected to the both springs. Your friend has two ends. Your friend is nothing but one spring and another spring. He has two ends, Sam also have two ends. Here both what? Connected, the both ends are connected like this. If you connect it like this, the both are, it means friend and me both are in parallel. Okay. Now, one is connected like this. One spring is connected to the one mass of the body, called it is the one body of mass m, and here it is connected, the one other spring is there, that another spring is connected, attached to the one another rigid support, and these are kept on a friction-based surface. Now these two springs are in parallel to each other. It means what? When you just apply one certain force on this mass, both springs starts to elongate or compress continuously. If you apply the some force here, it gets elongated, it gets compressed, and it gets elongated and it gets what? Compressed like this continuously. So it means what? If you, this is also rigid support, this is rigid support. When you connect it like this, what happened? This is a rigid support. One spring is connected to rigid support, and another spring is also there. Both are connected a single mass, that is m. It means then these two are like this. Both diagrams are same here. K1 and K2 are there. In this form, when the mass is just here, it means what? When the mass is under gravity, called is mg, gravity is there. When it's just elongated, it means when it's just under gravity, it is moving downwards. How much it is displaced? Call it displacement of the body as y. If it is a y, then what happened to the spring? Elongation of spring. The elongation of both springs is always same. It means what? The displacement in parallel combination, displacement is always same. It means in parallel combination, the displacement of the body is always constant, or same or here. It means y is constant. We have one formula that restoring force is equal to minus of k into y. Here y is constant. We want the value of k in parallel combination. Let kp is the effective spring constant. Effective spring constant in parallel. Take here parallel. F restoring force of each spring are different here, but only the spring displacement of spring is constant. Take the total force as a what? F1 and F2. Here, the total restoring force is there. The total restoring force FRE is equal to FRE1 plus of FRE2. FRE2 are there. Then you can take here. It is K1 and K2. It is called effective force or total force is there. If you take the total force, what happened using this formula? Kp is there. Kp is what? Effective spring constant minus Kp into the displacement is there. Then which is equals to minus of force 1 or force restoring force of the first spring. That become what? Minus of K1 is a spring constant of first spring and its displacement is same, and another one is minus of K2 into Y. Minus is minus one is there, minus into plus become minus, but I will take here the minus one as a common. Then minus of Kp into Y is equals to minus sign is common and Y is also common. Then that become what? K1 plus of K2. These two gets cancelled. Then what happened? Spring constant, effective spring constant in parallel combination is K1 plus of K2. Then what about time period? The time period is T is equals to 2 pi under root M by K is there. M divided by parallel combination is Kp. Then totally it become what? T is equals to 2 pi under root M divided by only K1 plus of K2. And what about the frequency? The frequency is nu. That nu is equals to reciprocal of time period, that is 1 by T, that is equals to 1 divided by 2 pi under root reciprocal of the term is K1 plus of K2 divided by M. These are the combination of spring parallel combinations, series combination. In next class we will discuss about the next concept, that is simple pendulum. Thank you.